Hi, this is Mohammed. Now I'm going to explain Python deep learning assignment 8, and my teammate is Yoma Desai. So let me explain the first part of the assignment. So here I will be using the diabetes data. So firstly, I will be inputting all the required necessary libraries. So NumPy, Pandas, and then Keras. The deep learning to build this model, and then standard scalar, then layers, for the filters will be adding here. For normalizing the data and then test it for this, putting the data set. So here I was printing the TensorFlow version 2.0, and then I was reading the data set. So and then I was moving the first 5 rows of the data set. So here you can see here the last feature is the target feature. So you can see only two numerical, so 0 and 1. So before building the model, so before training the model, if the machine learning and deep learning will perform only on numerical data. So I'll be checking whether my data, the diabetes data is having any categorical data, like non-numerical data. So here you can see the data types in the numerical form in terms of, and then I was checking like if there is any null data. So all the non-null data is 767. So there is no null data. And then here I will be converting the data frame into numerical arrays. And finally, I was printing the type. Here you can see it converted to n dimension array NumPy. So the size of the data set is 767 rows and then 9 columns. So and finally, I was splitting the data for training and testing. So yeah, the function. So first to 8 rows for the training. First to 8 rows are the first 8 rows. First 8 columns, and then last column is the target feature. These are the inputs, and this is the last column is the target. So the test is 0.25% of the data will be used for testing, and then random state I had given 42. So randomly taking the data. So I was printing the training and testing data. So you can see and then here I was building the sequential. I was building the model, sequential. So I was creating the object model, and then I was adding the dense layers. So dense 32 layers. So here it is 32 filters, and then input dimension I had 8 inputs. The activation function I had ReLU, and then 64 layers, and then finally the output will be in one. Output is one. Like I had only one, so I will be adding one layer here. So before executing the model, like before training the model, we need to compile. So I was compiling the model here. The last function is binary cost entropy, and then optimizer is atom matrix equal to accuracy. And then summary of the model here you can see. First the 32 layers, 64, and then for the output we had only one layer. We'll be passing to one layer. We'll be getting only one layer. So after training the model, so here I will be training the model. So we approach equal to 100. So 100 times it will be iterated 100 times. 100 iterations will be having. So you can see the accuracy 76%, and then finally I was evaluating on the test data. So the accuracy 71.35. So this is the actual, as per the source code, these are the layers it is in the professor had given. And now coming into the main functionality. So add more dense layers to the existing code and check how the accuracy changes. So I'll be adding more dense layers here. So I will be adding like 120 and two more dense layers we'll be adding here for the same existing model. And then I was compiling, and the summary of the model here you can see 32 layers, 64, 128, 250, and then finally the output is one layer. So one layer, so one filter. And then I was validating the test, adding the validation data test attribute to the fit method. So here you can see I was training the data. So fitting the train data, and then I was also adding the validation data X test, Y test. So after execution of training the data, here you can see the accuracies. So here the accuracy is 85, the training accuracy 85%, so it increased, and the validation testing accuracy 71%, 71.3, still the same, because as I was training the model for the multiple times. Here in the same, like with accuracy will be getting changed sometimes. When the first time it is increased and then again decreasing, and then it will be getting constant like that. So due to running multiple times, the accuracy changes. So then so we can also do like so I was evaluating, either we can add this validation data as a parameter inside the fit model, or we can directly add one more step, like we can evaluate directly on the test data, so it will both will give the same result. So you can see 70 point validation accuracy 71.35, and the loss like 90%, so both are same. And then finally, so so here you can see when I ran the first time, my accuracy got increased from 16 to 75. So due to running multiple times, it got changed. So every time, so we'll be getting like overfitting. So that's why. And then finally, we'll be plotting the accuracy for both training and validation. So here you can see I took the approaches for the approach for the x-axis and the accuracy on the y-axis. So for the training, it's like constantly increasing. For the validation, so it should increase, but a slight increase when compared to the previous one as approach increases. And then for the validation loss, here you can see so as the approach increases, the training loss should decrease. So it's good, but here for the testing data, it's like increasing. It is yeah, underfitting due to the multiple runs for the data. And finally, I was normalizing the data by adding the standard scalar. So creating the object, and then I was checking how the data looks like. So this is the data before. Then after normalizing, so our data will be changed to like 0 to 1 units. So here you can see like the low values. So I was not performing on the test data because it is in 0 to 1s, right? So that's why. And then the same model is built for this. Then after executing the model, after training the model, executing the model, I can see the accuracy is 72%. So there is a slight increase in the accuracy. Let me explain the second one. So in the same way, I was importing all the required set libraries, and then I was reading the data set breast cancer. And then the shape is the for 69,033 columns. So I was printing so I was the information about the data set here you can see. So I was checking any categorical data or, is there. So for the diagnosis, so I had a categorical data, so I need to convert to numerical. And then also checking any null data is there. So non-null data is 516, but for this unnamed feature, we'll be having NA. So let me check what the data is. So I was also reading the here statistical description of the data frames. Then I was reading the top 5 rows of the data set. So this is all the null values. So I will be removing this data set, and also I will be converting categorical data into numerical for the diagnosis feature. So now checking the unique feature count. So the diagnosis is having only 2 features. So mostly it will be the target feature for us. And then unnamed is all null value, so that's why it is 0. So we'll be dropping the feature. So dropping the online value. So ID also will be dropping because there is no ID feature has no any significance on the target feature diagnosis. So that's why we'll be dropping. And I was taking the unique data account. So for the B, it is a benign. The patient is we can find if the patient is malignant or benign. So finally, I will be converting the categorical to numerical, mapping into 0 to 1s. So my data set is like so everything is in numerical form, and then I can build the model for this. So firstly, we'll be splitting the data and then inputs like first 30 like accepted diagnosis, the remaining are the inputs, and this is the first one diagnosis, the output data, output future. So the test size like 25% for trying, 75 for training and 25 for testing. And I was printing the shapes of training and testing. So I was building them all similar as provided in the source code, like 6 dense layer, so 32 dense layers we will be adding. So like nearly 32 filters, so it will perform on the input data set. So input data like nearly 30 features, and then 16 passing through the 64 dense 64 layers, and then finally it will be having only one output, so only one layer to get. And then before executing the model, I was compiling the model, the functional, so binary cost entropy optimizer equal to Adam, and then metrics accuracy. So the summary of the model here you can see summary of the model, and then I was finally executing the model, building the model training. So extend waiting approach 100 iterations will be performed with the data set. So the here the accuracy is 88.97, 88%. Then I will be evaluating on the test data. So the accuracy now it is 92%. So now I will be adding the more dense layers for the existing code. So I will be adding the 128 this layer and 128 layers, and then 256 layers for the existing source code. And after compiling and executing and training the model, so my accuracy got the training accuracy got increased to 95%, and then testing accuracy got increased to 95%. Sorry, training accuracy got increased to both 95, and testing also 95. It's like nearly for the before adding the extra 2 layers, I got only 92, and now it is 95. I was plotting the graphs here. You can see for the training data set. Similarly to approaches on the x-axis and the accuracy on the y-axis. For the training accuracy is constantly increasing. The first similarly for the validation data also the accuracy got increasing, like in plotting the loss accuracy for both the training and testing data. So here you can see for the as the approaches increase, the validation loss decreases, like constantly decreasing. Similarly for the validation also it is like decreasing. So actually when training the model for the multiple times, we will be getting the like accuracy like increasing or decreasing. So the plots like it will be overfitting or underfitting. So we can reduce those, like we'll be having some extra features like taking more features. So to avoid this, like few are there. So one of them is like I will be adding more taking the more input data, like more features for the training and testing. So on the last one, I will normalizing the data by using the standard scalar, creating the object standard scalar SC. Then I was fitting the data fitting the data set, and then I will be transferring the data to the numerical form. You can see the data is transformed to numerical form, like in low values. The same model is built on the normalized data. So after execute of the training the model, you can see the accuracy, and then training 92% is now training, and then for validation testing accuracy it got into 97% from 95. So there is an increase in the accuracy. Okay, thank you.